Welcome back. In this video, I'm going to be working the 2023 AP Calculus free response number 3, which was the differential equation. Okay? I would have thought it would have been the graph of the derivative, but they switched it up on us, and the graph of the derivative was number 4 this year. So number 3, a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed, and okay, M is increasing, M is measured in degrees Celsius, and T is measured in minutes. Okay, we've got a differential equation for M and an initial condition. It can be shown. Maybe that'll be useful for us later. I'm not really sure where they're going there. A slope field for the differential equation is shown. Sketch the solution curve. Okay, this is one I hope you got right. Okay, so what we're going to do, we're going to follow the lay of the land, and we're not going to try too hard, right? I'm using a pen, so I've only got one go at this. Okay, and the rules are, when I have scored this type of problem in the past, it's been the curve has to extend to the edges of the slope field, and it can't have any flagrant contradictions against the slope field. So like, you know, a negative slope where it's supposed to be positive, or a zero slope where it's clearly supposed to be really positive, or something like that. So what we're going to do, we see it's got this, and we see it kind of like levels off towards that horizontal asymptote. So I'm just going to kind of make that happen and not try too hard. And what do you know? I've extended to the edges of the slope field, and I don't have any flagrant contradictions. Okay, that's what you do. Okay, that's part A. Part B, use the line tangent to the graph of M at t equals 0 to approximate M of 2, the temperature of the milk, at time t equals 2 minutes. All right, so I'm going to need a point and a slope. So what I've got is the point is time t equals 2, and they told me what the, no, t equals 0, we're approximating the temperature of the milk at time 2 minutes. All right, so at t equals 0, they told me that the temperature was 5 degrees Celsius. That's really cold. 0 and 5. The slope, I'll get that from the differential equation. So dm dt is equal to 1 over 4 times 40 minus the temperature of the milk, which is 5. So that's going to be 35 over 4. That's not the best number I've ever seen, but it's not the worst either. Okay, so this is something we'll be able to work with. And then I can write down an equation. So y, let's see, use the line tangent to the graph of M. Okay, we're just going to say y equals M of t. So y minus 5 equals the slope times t minus 0. Okay, and then my approximation is where I'm just going to plug in t equals 2, because that's what they want to estimate the temperature of the milk in 2 minutes. Okay, so I'd say M of 2 is approximately equal to what I would get from this for y if I plugged in t equals 2. So I'm going to add 5 plus 35 over 4 times 2 minus 0. And then that's my approximation. Part C is going to ask you to find the second derivative of M with respect to t both times. And then we're going to use that to determine whether the estimation from part B is an overestimate or an underestimate. Right now, I can tell you it's going to be an overestimate, right? Because I see that this curve is concave down. Okay? So the actual curve is going to sit below the tangent line. It's going to be an overestimate. Okay? But that's not going to be a good enough reason. I saw it on the slope field, not going to get you any credit. So I'm going to first find the second derivative. So I should write down the first derivative. dm dt is 1/4 of 40 minus m. So the second derivative of m with respect to t both times is going to be the derivative of this with respect to t. Okay, so it's going to be 1/4 of 0 minus the derivative of m with respect to t. So that's dm dt. And so that's going to be 1/4 of negative this, so that would be negative 1/16 of 40 minus m. Okay. Yes, that's where that disclaimer, I was wondering where that was going to come back. Okay, so at the beginning they said m of t is less than 40 for all values of t. So I know that second derivative of m with respect to t is negative for all because of what they told me, because m is less than 40. Okay. As a result, the graph of m is concave down. And what did they actually ask? I want to answer it correctly. Overestimate or underestimate? It's going to be an overestimate. Okay. over estimate. And that's part C. And part D, you guessed it, use separation of variables to find the expression for m of t. And fortunately for me, my class, we did a lot of practicing separation of variables right before the exam, and a bunch of them that were kind of like this. Very lucky. But we also practiced a bunch of polar, and I don't see any polar on there either. So, you know, sometimes you win them and sometimes you lose them. So what I'm going to do is I'm going to use separation of variables. I'm going to get all the m's over here. I'm going to leave the 1/4 there, and then I'll move the dt over here. So for part D, I'm going to have 1 over 40 minus m dm equals 1/4 of dt. And then I'm going to anti-differentiate both sides. So the antiderivative of 1 over 40 minus m, this is first power of m in the denominator, that's going to incur a natural log. So you would think to yourself, natural log absolute value of 40 minus m, but you know, with these you gotta take a second, take the derivative to check your answer, because there's going to be a chain rule implication here, right? 1 over 40 minus m times the derivative of 40 minus m for the chain rule, I'm going to need that to be negative, so that when the derivative of this, -1, comes out, it'll cancel, and I'll have just 1 over 40 minus m. Okay, an antiderivative for 1/4 with respect to t, that's going to be 1/4 t. We put the c on the side with the independent variable. Okay, now I'm just trying to solve an m, so I'm going to say natural log of the absolute value of 40 minus m is going to equal -1/4 of t plus c. And then I'm going to get rid of the natural log by taking e to both sides power. And now typically we say e to the c, you know, add it on. We could swing that around the front as a new constant. But I might drop the absolute values at the same time. Remember that it's going to give me a plus minus over here. Plus or minus c e to the -1/4 of t. Okay. And then I'm going to start solving for m by, you know, first step subtracting 40. Dividing by -1. And then now I'm going to use my initial condition to find out the value of c and whether or not this is a plus or a minus. Now, the fact that they told us that m of t is always less than 40 for all t, that's telling me that I'm going to probably need the minus here. But we'll use our initial condition and we'll let that guide us. So at t equals 0, temperature's 5. So 5, which is the temperature of the milk, equals 40 minus 35. So I know it's going to be a minus. Minus c times e to the -1/4 of 0. Okay, well, 5 is 40 minus 35, and e to the 0 is 1, so that's telling me c needs to equal 35. And so my, you know, final response here, my answer is going to be m of t equals 40 minus 35 e to the -1/4 t. And that's part D. That's the differential equation for this year. Thanks for watching.